Hello everyone, my name is Kelvin Michael.
I am Adegboye Gatiba.
My name is Joseph David.
And I am Edimo Amos.
And together we are team
Pissolo.
Hello everyone, my name is Adegboye Gatiba. I am the co-leader of the great team Pissolo, and the cause of this video is to talk about the need statement, the idea description, the competitive analysis, the technical summary, technical background, the concept details, the graphical concept representation, market analysis, cost and funding sources.
The IAS showed that 600 million people in Africa in the year 2014 were without electricity. Nigeria, the most populous country in the continent, has 60% of its population without electricity. That is why Team Pissolo is passionate about reversing the trend by the combination of simple technologies of management of human waste to generate electricity.
Pissolo need statement. The major cost component is the hydrogen generating plant, which is expensive to buy, but the full cost of ownership is far smaller than the power generators with environmental costs. When we see that other countries are moving to clean energy sources, we too must join the wagon.
The concept used in the generation of electricity is the combustion engine, and the fuel used is hydrogen gas. The hydrogen gas is produced by the concept of electrolysis, and the raw material is urea. We will redesign the current plumbing system to separate urine from other household and human waste and take it to a dedicated septic tank, from where we pump it to an electrolysis chamber and pass it through the anode of a standard hydrogen electrode to produce hydrogen gas. We will either bottle or pipe the hydrogen gas directly to the hydrogen gas fuel power plant.
Pissolo is a waste management and clean energy company that intends to collect, store and process urine into hydrogen for electricity generation. We intend to use our solution for large-scale communities such as college campuses, hotels and airports where large amounts of urine is collected every day. Ultimately, we intend to collaborate with hydrogen-powered generating plants so that we can make a system capable of generating hydrogen at the end point, which will also fuel the electrolysis plants at the end.
The typical household plumbing or drainage system is referred to as the DWV, which is the system for drain, waste and vent. Wastewater travels simply by gravity. In cases where a continuous slope is impossible or where wastewater must travel uphill, pumps are employed to move the wastewater. What we now propose to do is to separate the lines and septic tank for urine from those that carry other household waste, such as kitchen waste, bath waste, and water closet. Our whole idea works with three different systems combined in a very, very unique way. The first system is the sewage system, which collects the urine from cisterns and pipes it into a tank. From the tank, the urine is pumped into the second system, which is the electrolysis station or chamber. Electricity is passed through the urine, and since urea uses less electricity to break down than water, it will break down first into hydrogen, ammonia and nitrogen at the cathode and CO2 at the anode. The hydrogen will be bottled or piped directly to the power plant or stored in a gas containment unit. The protons pass through the electrolyte membrane, while the electrons are forced through a circuit generating electric current and excess heat. We plan to be an essential part of making the society cleaner and healthier for the future generations to come. Our solution will shift the attention of our major energy companies from using fossil fuels to look for avenues for renewable energy, create opportunities for able-bodied people, and provide different gases that companies need in their manufacturing processes. Technology already exists to produce electricity from methane using the same concept of our heat as our solution. However, the sewage system above, which produces the methane gas, is very expensive and very, very complex to build. But our system is relatively easy to build, as it simply redirects urine from urinals to dedicated piping and septic tank, from where we easily produce hydrogen gas for fueling the power generators. Researchers incorporated a photocatalyst in a moisture-absorbing, semi-conducting paint that can produce hydrogen from water in the air when exposed to sunlight. The technologies used in our project vary with both application and time discovered, but the principle behind our fluid motion, electrolysis, and the fuel cell are each very important to the running of our system. There are many zero carbon emission trending technologies that can compete with Pissolo's very great and explicit ideas, such as solar panel, wind turbines, electric water dam energy, etc. We feel our proposed concept is capable of continuous and more efficient use is based on the following arguments. Compared to solar and wind power, the source of fuel is not reliant on the weather and is more constant due to the fact that the production of urine is a daily process. Dam power depends partially on the tide levels to rise so as to produce enough energy from the water, but our fuel source is not dependent on atmospheric or environmental factors such as wind and tide flow. It would also be more cost-effective compared to fossil fuel generators due to their high cost of fuel. Finally, our generation system produces long periods of power supply. This is shown in tests conducted that showed that a liter of liquid compressed hydrogen is capable of powering a generator for at least 23 hours, that is most of the day, compared to solar panel systems that store electricity in large amounts, then their batteries later die off and leave the owners of the solar panel helpless.
The project would have many different types depending on the size or scale of the system. For instance, if our system were to be applied in a high-end residential estate, the cost range would be different from the ones used in a university campus. The largest scale systems applied on university campuses would have a total budget of over $45,000. Integration of the urine collection system and power generation system. In the smaller scale, systems like those in high-end estates and medium-sized estates, the price tag in the plumbing may be cheaper, but the total cost ranges will be at around $35,000 and $25,000 respectively. Therefore, our summary cost is only an indicative cost profile for a medium-scale development. The most important and costliest part of this is the plumbing schematic augmentation or total change, which price may range between $1,700 and $20,000. Moreover, the other major cost drags power generation, which will be gotten from manufacturing companies, form pre-designed dimensions.
Market analysis. Our solution is best suited to new infrastructure developments where we can design and build our pioneer sewage system into the architecture. But it can also be adapted by re-engineering existing sewage systems for residential and industrial estates, and even whole cities with extensive modern sewage systems. We will begin with new projects to build campuses for both public and private institutions. With success from these initial clients, we will advance to pursuing government contracts. Further, we will also manufacture special neighborhood and home systems that will create a commercial outlet for our business. Lastly, since our system will disrupt the building industry, we will have to bear the cost of training and retraining workmen and giving incentives to the tradesmen and project owners to try out our solution.
In the graphic representation of the system, urine is collected at various points in a tank. It is then separated into urea. This urea is passed through an electrolysis system that will separate into hydrogen and other components. This hydrogen is then purified through liquid borax and then stored or passed through the generator. Part of this electricity generated will be put back into the electrolytic system, creating a perpetual cycle.
We have an approved budget of $100,000 for research and development works from our parents, leading to proof of concept and initial designs and prototypes. When we have proved our concept, we will approach philanthropists, donor agencies, venture capitalists, and hedge funds for go-to marketing. For the summary of our costs and sources of funds, we plan to raise about 50% of the funds from our parents and their businesses, who are collectively our project sponsors. The remaining 50% will come from the following bodies: Conrad, GoFundMe, volunteers, and hedge funds and venture capitalist firms. In order to gather money to get the Innovation Summit in Lagos, Nigeria, Team Pissolo intends to look for sponsors to provide money to help take us there. In addition, Team Pissolo plans to partner with one of the leading energy companies to help bring our project and idea to real life and possibly make a working prototype. If Team Pissolo qualifies for the final round, which will hold in Florida, Team Pissolo intends to raise money to attend the summit from our parents.
Thank you for watching our video.
We are Team Pissolo.
All the way from Nigeria.
Wishing you a
Great day.